All right, I want you to try this one out, folks, all by yourself. What's the question? It says, are routers A and B addressed properly on the serial link connecting them together? So what do you need to do? Well, you need to figure that out. So are they addressed properly? Yes, or are they not addressed properly? So go ahead, pause this video, take a moment to go through this. And then once you have identified your answer, either being yes or no, unpause the video and we'll walk through it together. All right, so hopefully you've had that opportunity to answer yes or no to this question. So are routers A and B addressed properly on the serial link connecting them together? Well, how do we figure that out? That's the challenge here, right? How do I know for sure? You know, those addresses look pretty close together, 65 and 62. There's not a big difference between the two of them. There's only, 3 values difference. That's it. But now, you need to identify, well, for them to be addressed properly, they have to be in the same subnet. So are they in the same subnet? Again, they're very close together, 62 and 65. So you might be sitting back going, yeah, you know what? At first glance, they are. But wait a second. That's a guess. I want you to know 100% for sure. I want you to have the tools at your fingertips to figure that out. And I've already taught you those tools. So what is the tool we're going to use here? Well, we need to figure out the block size first. Because once we figure out the block size, we can take that block size number, count, and figure out what are the different subnets that we have. So when we're dealing with A/27, what is our block size? What is our block size? Well, /27 is 255, 255, 255, 224. Let's go ahead and use the 256 minus 224 option that we have. You could have done it all in binary if you wanted to. Would have came out with the same answer here of 32. But in this case, we said 256 minus 224 is 32. So we have a block size of 32. We're counting by 32 in which octet? Yeah, the 224 lives in the 4th octet. So in the 4th octet, we're counting by 32 in the 4th octet. So let's go ahead and do some counting here. We're going to have 192.168.1.0/27, 192.168.1.32/27, 192.168.1.64/27, 192.168.1.96/27. So let's see if we're right there. Let's look at some of these subnets. All right, 1.0, 1.32, 1.64, 1.96, 1.128, 1.160, 1.192, 1.224. So there's our subnets that we've created here. Now we need to identify who lives in what subnet. So where does .62 live? Where does .62 live? So go back to router A. Look at router A. 192.168.1.62. Where does that live? Which subnet? Is it in 1.0? No. Is it in 1.32? Yes, it is in 1.32. Because look at the next subnet. The next subnet is 1.64. The next subnet starts at 1.64. That means .62 lives in the .32 subnet. And what about .65? Yeah, you can see that now, right? You can see that .65 lives in the .64 subnet. So the answer to this question is no, of course not. Routers A and router B are not addressed properly on the serial link connecting them together because they are in 2 different subnets when they should be in the same subnet for proper communication.